Question number 4. Two cylindrical jars are shown at the right. When both jars are full of jam, what is the ratio of the amount of jam in jar 1 compared to jar 2? And so I'm going to show you actually two solutions to this. The first one involves just finding the volumes of the two of these and seeing how many times bigger the jar 2 is than the jar 1. So these are cylinders, so that's why we're using the volume of a cylinder formula. Notice my subscript here, so this is the jar 1, this is the jar 2 calculation. Pi r squared h is the volume formula for a cylinder. And so for the first one, the radius is 1, so we're putting 1 in place of r, and 3 centimeters is the height, so 3 goes there. And so this is what the calculations look like. So I would go pi times 1 squared times 3. Whoops, I did 2. 1 squared. So that's where my 9.42 comes from. And in the second one, the radius is 2, so 2 goes in place of r, and it's 12 centimeters high. So same calculation, pi times, I'll do the 2 right this time, times 12. And so that's where the 150.8 centimeters cubed comes from. So that's the volume of the two. So I want to know how many times bigger the second jar is than the first. I would divide them. So this is my calculation here. I rounded the two of them to 1 decimal place. Well, I guess I kept the 9.42 here. 9.42. And see, it's almost exactly. I did some rounding. That's why it's not exactly 16. So it's approximately 16, so that means the ratio of jar 1 to jar 2 is 1 to 16, or jar 2 is 16 times bigger, which is answer D. The ratio of jar 1 to jar 2 would be 1 to 16, so that means the second one is 16 times bigger in volume. Now, that's one solution, one way to look at it. Another way is to look at the volume formula and see what's happening to the radius. You know what's happening to the radius and the heights. They're not all changed by the same factor, but you can still use the volume formula to figure this out this way. So the radius gets doubled from 1 to 2 centimeters, and the height is 4 times bigger because it increases from 3 to 12. So if you look at the volume formula, so the radius again is being doubled from 1 to 2. So in place of r, I'm going to put 2r, meaning it's twice the radius. The height is 4 times bigger as it increases from 3 to 12. So in place of h, I'm going to put 4h because it's 4 times larger. H has been multiplied by 4, so it will be 4h. Now in the formula here, we're squaring the 2r. So remember, the 2 gets squared as well as the r. So 2 squared is 4, and r squared is r squared. And now there's no square here, so this is just 4h. And when I multiply this all together, 4 times 4 is 16. And then I have my pi, r squared, and h. So that's how we would simplify it. You normally put the constant, the number, on the front here. So that's why I put the 16 on the left side. Now, since the pi r squared h is the original volume formula, remember that's the volume formula for a cylinder, then 16 pi r squared h means it's 16 times bigger, because you see this, so this is the original volume, and over here, see, this part is the original volume. The 16 times it means it's 16 times larger. So again, the ratio would be 1 to 16. So that's another way to look at it for question number 4.